See, strategy for state space representation. Here, what is a state space? Graphical representation is called state space representation. Okay. See, state. What is a state space representation? State space is a graph representation of a problem where the node of a graph represent initial a partial solution in the problem space and the R are steps taken in a problem solving process. Okay, this is all about what is the state space representation. Now see, state space this strategy, there are two type of searching strategy. The one is the uninformed search, also called blind search, and there are three main type of blind search, means there are three main type of uninformed search. That is a depth first search, breadth first search, and iterative deepening search. Second one is a informed search strategy. This is also called heuristic search. The main searching strategies are hill climbing, best first search, greedy search, and A star. Okay, this is not in your syllabus simulated, and this is not available in your syllabus. Okay, now first of all, now I am going to tell you about the uninformed search, that is called blind search. See, what is a blind search? Let fringe is empty, return failure, node, remove first element from the fringe and assign to node. If node is a goal, then return the path from the initial node to a initial state to a node, and else generate all successor of a node and expand shallowest node first. Shallowest node first. Okay, and this is the feature of the breadth first search. Okay, add generated node to the block of the fringe. Okay, as shallowest means same label. See, this is the example. This is given. This example. Okay, first of all we will take node A, then search B, then C. Means top to down and left to right. We start searching from root and from top to down and left to right. A, then B, C, then D, E, F, G. Okay, we'll search continuously until we'll receive our goal. Okay, suppose G is a goal, then we'll start from root node A, then B, then C. This is a left to right. Then again come down and the next level and start from D, E, C, then D, E, then DZ, then C, F, B, and so on, and then G, and this is a goal. Then we'll start searching here. Okay, now see, using one example. This is the algorithm for the depth first search. Okay, here the feature of depth first search is generate all successor of node and expand deepest node first, while in case of breadth first search, expand shallowest node first. This is only difference between depth first search and breadth first search. Okay, see in example, depth first search. DFS means depth first search, that is a fringe is maintained as LIFO structure, last in first out structure or stack structure. Okay, see in this example, this is example. Here we start from node A and the goal state is a Z. Okay, this is a fringe, it's called list. In a fringe, first of all we put capital A, then initially fringe will contain node A. Okay, node A is a root node. Next step, A will remove from the fringe and its successor B and C will be generated and put at the beginning of the fringe. Means A will be removed from the fringe, then what is the successor of A? That is a B and C. So put B, C in place of capital A, that is a B, C in place of capital A. Now first node is a B, so B is removed from the fringe and we will check what is the successor of B. Check it. What is the successor of B? Successor of B is a DE. So put DE in place of B. So put DE in place of B. Now DEC is present in the fringe. Now we'll check what is the successor of D, because D is the first element of the fringe. Now D will remove from the fringe and its successor CF. What is successor of D? Successor of D is a CF. So we put a CF in place of D. Now the current situation is CFEC is available in the fringe. Now the first one is C. So C will remove from the fringe and its successor will put at the beginning of the fringe. What is the successor of C? C. The successor of C is G. So put here G in place of C. Put so we put G in place of C and keep remaining element as it is. At the next level, G will be expanded and found to be goal node. Okay. Now which one is the first here in this list? G is the first, and this is the goal state, and G goal will be expanded and found that G is itself goal node. So terminate our search after having found this goal node. Okay, this is the method of searching using depth first search. This is the example. Okay, it's the best example of depth first search. Now I am going to take same example for breadth first search. See, in case of breadth first search, we put root node here, then we'll check what is the successor of capital A, that is a BC. So replace capital A by BC. Now take first element from the list, that is a B, and what is the successor of B, that is a DE. So put DE, but not in the beginning, in the last. And we place DE but not at the beginning, in the last, and we remove B. Okay. Now which one is first? Now C is the first. Now we check that what is the successor of C. The successor of C is F and G. So write F and G in place of C but not at the beginning, in the last. F and G. DE keep it as it is and remove C, and the successor of C will put in, that is F and G, in the last of the fringe. Now which one is the first? D is the first. So take D is the first. So find out the successor of D, that is H and I. That is H and I. So put H and I in the last. Now find out the first successor of first element, that is E, that is J and K. So put J and K in place of E but not at the beginning, put it at the last and remove E from the fringe. Now this is the state C6. This is the current situation of fringe. Now which one is the first? F is the first. Then find out the successor of F, that is L and M. So put L M in the last of the fringe and remove F from the fringe. Now G is a goal. Now searching will stop here because G itself is a goal state. This is how we can search using breadth first search. DFS and BFS both are blind search technique. Okay, thank you. We will see remaining in the next video, recorded video. Okay, thank you.